So this is a video that only focuses on looking at atoms and molecules. Okay? So what I have is I have one setup of a problem that students tend to struggle with. The connection between moles and an actual count, for example, actual number of molecules. So in this one, we have to know that the connection is, for every 1 mole of anything, we have 6 Avogadro's number, 6.022 times 10 to the 23rd atoms or molecules of it. In this case, we are talking about molecules. So on this setup, you would take your 7.6 times 10 to the 25th molecules. Then you know this connection, 1 to 6.02 to the 23rd. So what goes on bottom is 6.022 times 10 to the 23rd molecules of CO2. And up above you have 1 mole of CO2. Okay. Then you would go ahead and divide. If you don't have a scientific calculator, I'll just take 7.6 divided by 6.022, and I get an answer of 1.26. It'd actually be 1.3 with significant digits times 10. When I go ahead and divide exponents, it'd be 25 minus 23 when I divide, and so that would be 2. So if I be times 10 to the second, okay, and that's the same as 130. So that's 130 moles, or 1 times 10 to the second, 1.3 times 10 to the second moles of CO2. Both would be okay answers. Okay. So the question I'm going to have you solve is real similar to that, and it is determine the number of atoms of aluminum from an atom count of 2.2, that's times 10 to the 21st atoms of aluminum. If you want to go ahead and stop the video, go ahead and stop it, work the problem out, and I will show you the answer. Okay, so hopefully you had enough time to do the problem. So you take the 2.2 times 10 to the 21st atoms of aluminum. Then you say 6.022 times 10 to the 23rd atoms of aluminum. That equals 1 mole of aluminum. Then you go ahead and do your calculation before. So on this one, I'll take 2.2 divided by 6.022 and get an answer that is 0.37. I go ahead and subtract exponents. In this case, I've got 21 minus 23, that's a minus 2. Then I'm going to move the decimal over 1 spot. That would be 3.7 times 10 to the minus 3. And that would be atoms, be moles of aluminum. Atoms. Okay. All right. If you want to do another example like that, you can look at 7.3 on page 198, and the answers are in the back.